Now, up to this point, we talked about equation. Now we talk about inequation or inequalities. Right? So here you would, when you solve an inequation, you would not have a unique answer like one number. You would have a range of number. And that range of number can be shown as a graph or can be shown as an interval. For example, here we are showing that x is between 3 and 7, exclusive of 3 and inclusive of 7. Right? X is greater than 3, less than or equal to 7. In the form of a graph on the number line, we're going to show a 3 here and put parentheses. Why parentheses? Because there is no equality here. And 7 is to the right, or is larger than 3, so it will go to the right. And we put a bracket. Why bracket? Because there is equality. So we say the answer is between these two, including the 7. 7 is included. Or the answer might show as x greater than 5. So on the number line, we show where 5 is, so 0 is somewhere here. And face it, since it says it's greater than 5, face it toward the right, toward positive infinity with the parentheses, since there is no equal. So the answer is to this side, you go toward positive infinity. Or x less than or equal to minus 1/3. So on the number line, we show a minus 1/3 here, and face the bracket because of the equality, face the bracket toward minus infinity because we say less than that. So the answer is to this side. Anything to that side, including the minus 1/3. You can show that in the form of the interval. You can show that in the form of the interval also. You can show it as parentheses 3 and 7 with bracket, right? These are all the same answer. 5 and infinity with parentheses around it because it's 5 is greater than 5 toward infinity. Since infinity is not a number, we can never say put a bracket next to infinity, whether positive infinity or negative infinity. So infinity would have a parenthesis between 5 and infinity. By the way, this is 1.9, if I forget. We get into 1.9. And minus infinity and minus 1/3. It starts from minus infinity and it goes to minus 1/3, including the 1/3 with the bracket. And here it would explain that parentheses means not included in the solution, and brackets means it is included in the solution. These are all the different forms in the form of interval, graphs, and these are the example. Where the answer is 3 and 5, that means the answer is between 3 and 5, exclusive of both, between 4 and 7, inclusive of both because of the bracket, between minus 1 and 3, exclusive of minus 1, inclusive of 3, and so on and so forth. Greater than 1, exclusive of 1, less than 2, exclusive of 2, and so on and so forth. These are the different forms of answers you may have when you solve an inequality. We're going to do that in just a moment. How to solve an inequality. Solving a linear inequality as you would solve a linear equation. However, If you multiply or divide by a negative number, you should remember that you must reverse the inequality sign. Remember, under the rule of the equation, we said if you add, subtract, multiply, or divide a constant to both sides of the equation, nothing would happen. The equation is still true, right? Here it would tell you you can add or subtract. You can add or subtract anything to both sides of an inequality, nothing would happen. You can multiply or divide by a positive number, by a positive real number, nothing would happen. But if you're multiplying or dividing by a negative number, you should reverse the sign of the inequality. Okay? Very important to remember. So let's see how we do this problem here. It says solve 3x plus 2 greater than 17, right? So what do? Like we do an equation. We take the 2 to the right-hand side, or we subtract 2 from both sides, either way you want. So it would be 3x greater than 17 minus 2. So that would be 3x greater than 15. Next, we divide both sides by the coefficient of x. Since the coefficient, which is 3x, is positive, nothing would happen. So divide by 3, divide by 3 on both sides. So it would be x greater than 5. That's the answer. Any value greater than 5, not including 5, is the answer. That means we'll keep this inequality true. So what value greater than 5? Let's say 10. Let's say h is equal to 10. That is greater than 5. H is equal to 10. So we go and plug in for h 10 and see if it would end up being greater than 17. So 3 times 10 plus 2, it should be greater than 17. 3 times 10 is what? 30 plus 2, it should be greater than 17. 30 plus 2 is 32. It should be greater than 17. And it is. 32 is greater than 17. So that's a test that any x value greater than 5 would satisfy this inequality. As I said before, with the equation, when you solve equation, you come up with a single answer. You come up with the exact answer. Here, either 1 or 2 or 3 answer, but you come up with the exact. Here, with the inequality, you come with the range for your answer. So in this case, the range is anything greater than 5 would do. Anything greater than 5 would keep the inequality true. So get rid of this. And see what they have done. Okay, take 2 to the other side, 3x greater than 15. Divide both sides by 3, you get x greater than 5. So between 5 and infinity, exclusive of both. Between 5 and infinity and exclusive. So they are shown in the form of an interval. By the way, I can do it on the number line the same way, going toward infinity, minus infinity, and 5. I put a parenthesis here, 5 right here, and it goes to this direction. So minus 4/5 x greater than or equal to 8. This is another example. Minus 4/5 x greater than or equal to 8. Now, in this case, I'm going to multiply both sides by the inverse of this coefficient with the same negative sign. Okay? Since I'm multiplying by a negative number, this would reverse. This sign would reverse. So I'm going to say I'm going to say minus 4/5. I'm going to say minus 5/4 multiplied by minus 4/5 h. Now the sign has to reverse. Now it would be less than or equal to 8 times minus 5/4, the inverse with the same sign. So minus 5/4 times minus 4/5 h, minus and minus would be positive. 5/4 times 4/5 would be 1. So on this side I have x less than or equal to 8 times minus 5/4, 8 and 4, that would be 2, is less than or equal to 10. Minus 10. Less than or equal minus 10. Okay? So anything less than or equal minus 10. So if I want to show it on the number line, let's say minus 10 is here. Less than or equal, so it would be a bracket facing in this direction. And it goes in this direction. That's the answer. A range of numbers, anything less than or equal 10 would do the job, would keep this inequality true. Okay, let's see what they have done. Multiply by minus 5/4. The reason minus 5/4 is to make this 1. We want to make this coefficient equal to 1. And x, okay. That is not correct. That is not correct. It has to be less than or equal to minus 10. I made a mistake. It has to be minus 10. Because less than or equal 10 would not do. You understand? If, let's say, less than or equal 10, like 0. Like 0. So minus 4/5 times 0 is what? Is 0. Is 0 greater than or equal to 8? Nope, it's not. So this has to be minus 10. So on your slide is not correct. Change that number. Good thing we saw that. Okay. Now, you can have inequalities, quadratic inequality, right? Not just a simple linear one. Now you have a quadratic inequality. You have x squared minus 4x minus 12 less than 0. Less than 0. Okay, so you're gonna write this as, factor it, write it as 2 parentheses, and the result should be less than 0. So x here, x here. Now two numbers that multiply by each other would give you minus 12, and when you add them together, it would give you a minus 4. Okay? I assume it is 2 and 6, right? A 6 probably has to be a negative, and a 2, now that we are master at this, we don't have to do the real trial and error. Let's see if this would give me this same inequality I have here. You would have x times minus 6 minus 6x, and 2 times x plus 2x minus 6 plus 2x is minus 4x. So I'm okay here, right? Okay, now this is a little bit different than what we have done. I'm going to put the number line and positive infinity, negative infinity here. identify where 0 is right here. The first thing I have to do is to find the two critical points by setting each one of these expressions equal to 0. So one, I say x plus 2 equals 0. That means x is equal to minus 2, minus 2. That is one critical point. The second one, x minus 6 equals 0. That means x is equal to 6. These are my two critical points I have to identify on this number line, right? If this is 0, then I would say 6 is probably somewhere here to the right, a positive 6. And negative 2 would probably be here as negative 2, right? Then the next question I ask is, for each one of these, let's say x plus 2, which one of these critical value would make this equal to 0, right? Well, we set it equal to 0 and we came up with minus 2. So it's right here. It's right here. You get a 0. Now, if you put a value above this minus 2 into here, would you get a positive number or negative number? So pick one thing, easy. What if it is 0? X is 0. What do you have? Well, 0 plus 2 is what? Plus 2, which is a positive number. So you put positive all the way through. If any value less than minus 2 is put into this equation, like minus 10, you have minus 10 plus 2 is minus 8. So you would get a negative number. That's really what you have to do. If one side is positive, the other side is definitely negative. So that's one. For the second term, you have x minus 6. X minus 6. The critical value, or what makes this 0, is 6. Now you ask the same question. Let's go with 0. If x is equal to 0, what do I get? If x is equal to 0, 0 minus 6, I get a negative number. So anything to the left would be negative. Greater than 6, I would have a positive value for that expression, right? That takes care of this. Now their product, x plus 2 times x minus 6. Well, where one of them is 0, such as x plus 2 being 0, then 0 times anything would give this product also 0. And the same thing here. When x is equal to 6, it would make this 0. 0 times anything is also 0. So those are for certain, right? You would have 0. Then to the left of minus 2, look here, to the left of minus 2, you have negative for x plus 2, you have negative for x minus 6. But so when you multiply negative by negative, you multiply them, what do you get? You get a positive. Between minus 2 and 6, x plus 2 would be positive, x minus 6 would be negative. Positive times negative is what? Is negative. Now above 6, x plus 2 is positive, x minus 6 is also positive. So what do you get? You get positive all around. So now you identify where this product would be positive, where it would be negative. However, if you look at what we want this product, the product of these two, to be negative, less than 0. Where would it be negative? Right here. So it is between 2 and what? And 6. Exclusive of those two. Exclusive of those two. So the answer is between minus 2 and 6. Or if I want to do it on number line, I have 2 here. I have minus 2 here. And I have 6 here. Put parentheses. It would be between these two. That's the answer. So that's for the inequality which is quadratic. Okay. So first you factor it. Then for each one of them, find the critical points, which is what we did. What makes them 0. Then you do on your number line and you come up with the answer rather neatly and quickly. Let's see how they did it. Remember the way I done it and look at the way they have done it and choose your way. One might be easier for you to grasp. So whatever is easier for you to grasp, just follow that and solve these inequalities that way. Okay, factor, right? H minus 6 times h plus 2 less than 0. Then the roots, or critical point, I call them the roots, are minus 2 and 6. What makes each one of these parentheses 0? Then determine the values for which the product is negative using the sign chart, or the number line I call it. So it has this critical point or these roots. And for this product, for the sign of this product, so it didn't do it each one of them individually. It went straight for the multiplication of the two products, these two. So it shows it's between minus 2 and 6, which is negative, which is what we want. Therefore, the answer is between minus 2 and 6, exclusive of those two values. One more topic in this chapter, and that has to do with absolute value. Absolute value. Definition of absolute value first. Absolute value of A equals A if A is positive or 0, and is equal to minus A if A is negative. So what does it mean? Absolute value of 5 says if A is positive, which is, then absolute value of that A, since it is positive, would be equal to A, is equal to 5. Done. On the other hand, absolute value of minus 2, well, it says if A is negative, A is what you have between the two absolute values. If A is negative, then the absolute value of the negative number would be negative of that negative number. So it's negative of negative 2, which is equal to 2. This is, you normally say you take the absolute value of a negative number, we get rid of the negative sign. But this is a logic for it, right? So based on this, we can evaluate absolute value of 3 minus 8 equals absolute value of minus 5, right? And since A is negative here, since A is negative, that would be negative of negative 5. Negative of negative 5, right? Because A was negative. So that would be equal to 5. That's how you evaluate terms in between absolute value. Now look at this example. Absolute value of, let me just do this. Absolute value of 5 minus 2 minus absolute value of square root of 5, that wasn't 5, square root of 5 minus 3. Okay. So first we have to figure out in between these two absolute, are we going to have a positive number or negative number? Square root of 5, how much is the square root of 5? Well, square root of 4 is 2. I know that. So square root of 5 would be something more than 2, right? So something more than 2 minus 2 would be a positive number, right? So this here would give me a positive number. So what I have in between absolute value is positive. So that is equal to what I have between the absolute value. So I just get rid of the absolute value sign. It would be square root of 5 minus 2, right? Minus this minus, right? And put parentheses for you. Square root of 5 minus 3. Okay. Now square root of 5, I know it's more than 2, but it's not equal to 3. Because it is absolute value of 9, which is equal to 3. Or square root of 5 is equal to 3. So square root of 5 minus 3 is going to be a negative number. It's going to be a negative number. So since a is negative, it would be negative of this. So it would be negative of square root of 5 minus 3. Now, square root of 5 minus 2 minus, first I apply this negative into this, so it would be minus square root of 5 plus 3. Now, one more time, square root of 5 minus 2. Now this negative applied, distribute to this parenthesis, it would be plus square root of 5 and minus 3. So what would we get? Square root of 5 plus square root of 5 is 2 square root of 5. And minus 2 minus 3, it would be minus 5. That's evaluating that with the absolute value. Okay. Again, as usual, we're going to clean this and look at the slide itself and see how they done it. Okay, since this was positive, they write it as is. But since this was negative, they change it. They didn't put two parentheses on only one. They just switched the place, made this one negative square root of 5, and negative 3 become positive 3. Now apply, distribute the negative to it. It would be 2 square root of 5 minus 5, which is the same thing we just had a moment ago. Now here are some properties of absolute value. Properties of absolute value. Property number one, absolute value of minus a is the same as the absolute value of a. In both cases is equal to a. We just saw that. So absolute value of minus 5 equal minus 5, which is equal to 5, which is the same as absolute value of 5. So both absolute value of 5 and absolute value of minus 5, both of them would give you what? Would give you 5. That's the key right there that make these two equal. Absolute value of a times b can be written as absolute value of a times absolute value of b. So in other words, you can separate them. The same thing you could have done with radical. So absolute value of 5 times minus 2 can be written as, well, can be written as 5 times minus 2. And this is the way they do it. Absolute value of 5 minus 2. 5 minus 2 is minus 10, right? Absolute value of negative number would be negative of that negative number, negative of negative 10, which is equal to 10. Now that is the same as absolute value of 5, which is 5. Absolute value of minus 2, which is 2. 5 times 2 is also 10. when you have division between the absolute value, you can separate the numerator from denominator also. So absolute value of a divided by b equal absolute value of a divided by absolute value of b. So for example, minus 5/9 absolute value of it would be equal to minus 5/9. So the negative can be in front of here either way. Well, it's a negative number. So when you take the absolute value of it, it will become positive, is 5/9. And that is the absolute value of 5 over the absolute value of 9, which is also 5/9. Again, the key to these that makes these the same is this number. Either this one and this one, either one of them end up being the same. End up being that number. Finally, absolute value of a plus absolute value of a plus b less than or equal absolute value of a plus absolute value of b. How do we do that? Absolute value of minus 3 plus 7, right? Minus 3 plus 7 is 4. Absolute value of 4 is equal to 4. Now let's separate them. Absolute value of minus 3 plus absolute value of 7. Absolute value of minus 3 is what? Absolute value of minus 3 is 3. Absolute value of 7 is 7, so that is 10. So 10 is greater than or equal to 10 is greater than or equal to 4. That's what it says. Greater than. When you separate them, it would make it greater or equal. In this case, it made it greater when you separated them. Okay. Discard all this. Let me just see if anything is missed in this chapter before we think of another chapter. Again, the problems at the end of the chapter, the exercises are in a separate set of videos. Please make sure you study all those also. Okay.